All right, everybody, so now that we know that 1 mole is represented by the mass on the periodic table, we're going to go ahead and move on here. So there's something called molar mass, and it's something you've already been working with when you were looking up your masses on your periodic table. But we're going to write in a definition here. It is the mass in grams of 1 mole of an element or compound. Okay, and you're able to find this molar mass for all elements or all compounds on the periodic table. Okay, and in this class, we're going to round the molar mass to the nearest whole number. Okay, because all of them on the periodic table are in decimal form, and we're just going to go ahead and round that to the nearest whole number. Okay, so you guys were working with single elements on our Part 2 notes, where we were just looking up a single element and writing down the mass of that. However, we can determine this molar mass for a compound as well by adding up the mass of each atom of each element in the formula. Okay, so let's say that we have 1 molecule of water. So we've got an oxygen molecule here, a little oxygen. Its mass is 16. All right, if we look that up. And then each water molecule has 2 hydrogen molecules bonded to it, and each of those is 1. Okay, so the mass of a single water molecule would be 18 atomic mass units. Now, if we have a mole of water molecules, so let's say we've got our beaker here, we've got 1 mole of water in there. Okay, that's also going to be 18. It's going to be 18 grams, and since there's a mole of it, the units we use for that is 18 grams per mole. So we're going to say that molar mass is 18 grams per mole. Okay, now we can do the same thing with any compound. So, for example, we've got sodium chloride, NaCl. So we've got sodium here, chlorine here. If we look up sodium, its mass is 23. Chlorine's mass is 35. Okay, and so if we were to take a block of salt, oh wow, can't draw a box here. If we were to take a block of salt, so this is sodium chloride, and we said that this was 1 mole. We have sodium and we have chlorine, 23 plus 35, is going to give us a molar mass of 58 grams per mole. Okay, so it's simply adding up the masses of each individual element within that compound. All right, so let's do some practice problems on the back. We're going to find the molar mass first of lithium oxide. Okay, so the first step in all of these problems is writing the correct formula. So we need to look up lithium on our periodic table. It's Li, and it has a charge of +1. And then oxygen is O. It has a charge of 2-. So a correctly written formula, if we crisscross the charges, is going to be Li2O. Okay, if your formula is not correct, you will not get the correct molar mass. Okay, so now we're going to list out what we've got. We've got lithium here and oxygen. Okay, now I need to count up how many of each that I have. So I have 2 lithium and I have 1 oxygen. We're going to multiply that by the molar mass of each of these. So we look up lithium. Its mass is 6.9. We're going to round that to 7. 2 times 7 is 14. So the total mass of lithium in this compound is 14. We're going to look up oxygen. It's 15.9. We'll round that to 16. 16 times 1 is 16. The total mass of oxygen in this compound is 16. So now to get the whole molar mass for lithium oxide, we just add those two numbers together. 16 plus 14 gives us 30. So our answer is 30 grams per mole of lithium oxide. Okay, let's try another one. Copper nitrate. Okay, so we need to write the correct formula for copper nitrate. Copper has a 2+ charge here. Nitrate, NO3, is a 1-. So a correctly written formula should be CuNO3 2. Okay, so we're going to do the same thing as we did in problem 1. We're going to break up the elements. So we have copper here, nitrogen, and oxygen. In the formula, there's 1 copper. There are 2 nitrogen. Remember that whatever's outside of the parentheses distributes to whatever's inside the parentheses. And then I have 6 oxygen. Okay, so now we just need to look up the individual masses for each of these. So we've got copper. It is 63.5. We're going to round that to 64. 1 times 64 is 64. Nitrogen, we look that up. It is 14.0. Round that to 14. 2 times 14, 28. We look up oxygen. It is 16. 6 times 16 is 96. So to get the molar mass for the whole thing, we add those 3 together, and we're going to get 188 grams per mole is the molar mass for copper 2 nitrate. Okay, what I'd like you to go ahead and do now is take out worksheet number 2 and do practice problems 1 through 4. You're just calculating the molar masses for these compounds. So you're looking up, just like we did here, each element, how many there are in the compound, and then calculating their molar mass.